right? It asks us to find AC if we already know A, B, and BC. Okay, so if I write, first I'm going to write my segment addition postulate equation like we always do. So we have AB plus BC equals AC. All right. We know that AB is 14 and BC is 5, so I can just plug that in. And that means that AC must be 19. Okay. So my answer here, AC equals 19. Remember, you have to write that AB plus BC equals AC equation, though. If you don't write it, that'll be 4 points off. And this kind of problem would be worth like 6 points. Okay. On part B, it asks us to find BC. Well, I can use the same equation, AB plus BC equals AC, and plug in what I know again. So I know AB is 16. I don't know BC, but AC is 23. And then you would just solve this like you would any equation. So subtract 16 on both sides, and BC equals 7. Okay. So again, you have to start with that equation. For some reason, some of us, when we have these problems where we're trying to find AB or BC, we want to write it like this. But that's not what I'm looking for. I'm looking for AB plus BC equals AC. Okay. Remember, I told you that your equation you write shouldn't have minus signs in it from the beginning. Should always be addition signs. That's kind of like your hint to if you're doing it wrong. Which, I mean, it's not necessarily wrong, but it's not what I'm looking for. Okay. So don't do this. Make sure you do that. All right. Any questions about that one before I move on? Dallas, you following with us? Yeah.
So if we do AB plus BC equals AC, can we just, instead of subtracting it, or for part B, instead of just subtracting AC and AB, can we just subtract it in the calculator and then just write 16 plus 7?
Yeah. Yeah, you can do that. Also, if you write AB plus BC equals AC, and then you write this, because that's the way you like to see it, that's fine as long as you have that part over there. Okay. Yeah. Any other questions? Okay, number 2. We have this line here, and it's asking us to find XY. So we always start the same way with our equation, which here would be XY plus YZ equals XZ, right? We know that XY is 4x plus 1. YZ is 15. And XZ is 7x plus 1. All right. So we combine like terms. Here I have 4x plus 16 equals 7x plus 1. Okay, I'm going to, can y'all see that? I'm going to subtract 4x on both sides. So I have 16 equals 3x plus 1. Then I'll subtract 1 from both sides. 15 equals 3x, and then divide by 3. And 5 is equal to x, okay? So any questions about how I found x, any of those steps? Asa, you with us? Oh, you can't see it. All right. I know x, but it asked me in the problem to find xy, right? So, was this the one you had a question about? So it tells me here that xy equals 4x plus 1. So now that I know x, I'm going to plug in 5 for x. And I see that xy equals 21. So to get full credit, you had to find x. Well, first you had to write your xy plus yz equals xz. Find x and then plug your x, substitute your x back in for x to find xy. Questions? Good? Okay. All right, if we look at part 2 here, this was supposed to say xy, this should be yz, and this should be xz. But it wants us to solve for x. And we're looking at the same line segment, so we know that our equations should be the same. And I want to emphasize that last time when I was grading the quizzes, I saw that we would write an equation here on part A, but get a different equation on part B. Well, if we're looking at the same picture, and the equations are based off the picture, then they should be the same equation on both parts. All right. So don't change your equation from part A to part B. So if on part A I wrote xy plus yz equals xz, I'm going to write the same thing on part B because we're looking at the same image. Okay. So I know xy is 4x plus 9, yz is 5x plus 2, and xz is 56. So if I combine like terms, I have 9x plus 11 equals 56. Subtract 11 on both sides. 9x equals 45. And then divide by 9. And x equals 6. All right. Okay. Any questions about that?
45 divided by 9 is 5.
Yes, it is. Yeah, 45 divided by 9 is 5. Sorry. 9 equals 10, 36, 45. Yep. Okay. All right, go ahead and move on. So this is where a lot of people struggle. So with the angle addition problems, we're going to do them pretty much the same as we did the segment addition. Right, if I'm looking at part 1, first thing I need to do is write out my equation here. So I have the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Okay. I know that AOB is 18, BOC is 19, so AOC must be 37. Okay, so the measure of angle AOC is equal to 37 degrees. All right, then I use the same equation for number 2. I know that AOB is 29. I don't know BOC. And AOC is 48. Okay. Subtract 29 on both sides, and I get that the measure of angle BOC is equal to 19. All right. 19. Okay, moving on to the next problem. It wants us to find, why can't you just do 48 minus 29? Well, that's pretty much what I did. Without writing all that other stuff? Well, because the important part, the main part of the unit is that you understand their postulate. So I want to see you write it out. Pretty much. I subtracted, yeah. 29 from both sides.
I don't know why I thought we were supposed to have. You subtract them every time?
It's just like if you had an equation, let's say if it said 29 plus x equals 48, then you know you subtract because you do the opposite, right? So it's the same concept. Treat this measure of angle BOC, treat it like it's an x or something in your equations. Okay. So here on number 5, part A, we're going to start the same way we always do. So I have the measure of angle LMV plus the measure of angle VMN equals the measure of angle LMN. Okay. All right, so do we understand how I wrote that equation? Yes? Yeah, you understand how I wrote that equation? So the way that here's the way that I broke it down to some kids. I think in my 7th period, and they understood it. So if you think of this as like a pizza, right? It got 2 slices left in it. And you have 2 slices of pizza that make up the entire pizza, right? So the first thing that we do is we find the name of this slice of pizza up here, right? So if I look at that slice of pizza, the name of it would be LMV. Okay, you see that? The name of that slice of pizza would be LMV. So when I come over to my equation here, that's where I get the measure of LMV. Okay. So then I have to find the name of this second slice of pizza. And if I look at the endpoints, it will be VMN. And so that's where I get the measure of angle VMN. Then I have to name their entire pizza itself, which is from L to M to N. So those 2 slices added together make up the entire pizza, which is LMN here, and that's where we get that from. So now that we've done that, I can substitute in for what I know. I know LMV is -1 plus 45x. VMN is 23x. And LMN is 135. You said what now? Oh, yeah. So you got -1 plus 68 equals 135.
You didn't add the
68x, yeah. Then you add 1 on both sides, and you see the 68x equals 136. Divide by 68. And x equals 2. Okay. So here, x is equal to 2. Can't hear you.
Oh, I was just saying in Spanish.
Oh, okay. Those, yeah. If you know that. Dallas, did you get that? Yeah. Sure. Yeah, we'll get there in a second. Okay. All right. Part B is basically the same thing. Except after you find x, you have to go back and plug it in. What time is it? I guess I'll go through it. We have time. All right, so the first thing I'm going to do again is write my angle addition postulate out. So I have the measure of this top slice, which is Wij, plus the measure of the bottom, which is Hiw, equals the measure of the entire, which is Hij. All right. I know that Wij is 10x, so I have 10x plus 2x plus 13 equals 145. Right. So I'm going to combine like terms again. I have 12x plus 13 equals 145.
What's it in?
Okay. Just continue till I solve for x. All right. So x is equal to 11 if I go through all those steps to solve for x. Now, it asks us to find the measure of Hiw. It tells us up here that the measure of angle Hiw equals 2x plus 13. Now I know x is 11. I can plug in here. So 2 times 11 plus 13, which is 35. So the measure of angle Hiw is 35. Questions about that one? Nope. Spencer, you good? Okay. No questions, I'm gonna keep going. All right, so we're here. We're gonna determine the distance from A to B. Remember our distance formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. So I can label my x's and y's here on my points. Then I'm just going to choose A to be number 1 and B to be number 2. Okay. Okay. Now if I substitute in my values here, x2 is 9, x1 is 3, so 9 minus 3 squared plus y2 is 10, so 10 minus 8 squared. Right. 9 minus 3 is 6, so here I have 6 squared plus 2 squared. Okay. 6 squared is 36, and 2 squared is 4, so you have 36 plus 4, which is just 40. The perfect squares? All right, so now, if I get my list of perfect squares here, I have a list right here. If I can, yeah, I'm put it over here. So I have my list of perfect squares. And I can use my calculator. So I can use my calculator here, look at my list of perfect squares. The way that we say it, let me make my calculator a little smaller. The way that we said we would do this is we would find the first perfect square that's smaller than 40, right? So I would start here with 36 if I'm looking at my list. So I have 40, oh my, here, where's the remote? Yeah, I know. 40 divided by 36, that will give me a decimal. Keep going down. 40 divided by 25 is a decimal. Try 16. That didn't work. Try 9. That didn't work either. Okay, 40 divided by 4 is 10. All right, so I went down my list of perfect squares until I found until the result was a whole number, all right? So 40 divided by 4 is 10. So if I move this stuff out the way. All right, so I know that, and I'm gonna go up here now. I know that 40 equals 4 times. I know that 40 equals 4 times 10, so I'm gonna write this as the square root of 4 times 10. Okay. I can separate these. And I know the square root of 4 is 2. So I have 2 times the square root of 10. Yeah, that's it. Okay. So I'll say, because I think the test might be kind of long, I don't know. I can do the test in like 10 minutes. Huh? That's what I'm saying. I won't say I'm smarter than y'all, but I always. Okay, I'm gonna keep going. Let me move this stuff out the way. So we have these 2 points. We want to find the midpoint. This is the one y'all are asking about. So remember, the midpoint is just x1 plus x2 over 2 and y1 plus y2 over 2. Okay. So if I look at my x values, I'm going to add those together. 5 plus negative 10 and 2 plus negative 2 are my y values. I'm going to add those together. 5 plus negative 10 is negative 5. Huh? Too fast?
Yes.
Oh, sorry.
Wait. I did that wrong.
Okay. So this top where I wrote xy plus x2 over 2, that's the formula. Yeah, you don't change anything in the formula. You just put in. You're thinking about distance formula. That's a different formula. Okay. Keep going.
5 over 2, you go x1, y1, you go x1, x2.
Huh?
Like doing the x1 and x2.
Mm-hmm.
Like in 5 and 2, if you go x1, y1, you go x1, x2.
Oh, yeah. So it's always x1, y1, x2, y2. All right. Yeah. Yeah, I did skip that part. Okay, so we're good now to keep going? Yes, I'm assuming yes. Okay, 2 plus negative 2 is 0. And then if I just simplify here, I'll get negative 5 over 2, comma 0. And that's the midpoint. Questions?
So if you have a number on the other side, now,
I can't hear you.
if you have a number on the other side,
Okay, find the length of AB. So this is part B. It's asking about the same points, so I'm going to rewrite them here. 5, 2, negative 10, negative 2. So if it's asking us to find the length of that segment with these endpoints, what formula are we going to use? Distance formula, yeah. So if I use the distance formula here, x2 minus x1 squared plus y2 minus y1 squared. Okay, so with this, I'm going to label my x's and y's, and I'm just going to choose this ordered pair to be the first pair, and this one be the second. Remember, when you're doing distance, it doesn't matter which one is first or second. Okay. All right, so if I substitute in x2, I got negative 10 minus 5 squared plus negative 2 minus 2 squared. Right, yeah. So I have negative 15 squared plus negative 4 squared. Okay. Now 15 squared is 125? No, it's 225. So I have the square root of 225 plus negative 4 squared is 16. So this is equal to the square root of 241. Yeah. You good, Tucker? Okay. And then we have one more midpoint problem here. Okay. I'm going to take my x values and add them together. So I have negative 1 plus 5 over 2. My y values. Add those together. Yeah. Negative 1 plus 5 is 4 over 2. 1 plus negative 5, that's negative 4 over 2. Then if you simplify, you get 2, negative 2. Okay. Then it says plot the point, so you just plot it. It'll be over here somewhere. On the test, you'll have a coordinate plane that actually prints correctly, hopefully. All right, any questions about the study guide that I didn't answer already? So we feel good. Okay, so we're going to find, first, it asks us to find the horizontal change from point A to point B. Now, we should remember from our notes that horizontal change is going to be our x2 minus our x1, right? X1. All right, so if we label our points here, we should have x, y, x, y. Since we're going from A to B, A is our first point. So this is my x, y1, and the B is my x, y, x2, y2. Okay. So if I do x2 minus x1, that's going to give me 6 minus 0. And we want 4/5 of that change, so I'll multiply by 4 over 5 here. Okay. So if I simplify here, 4 over 5 times 6. And I know that that is 24 over 5. Now, what if you don't know that? Then in your calculator, if it ever comes up. Okay, in your calculator, if you don't know how to add and multiply fractions, if you press alpha y equals on your calculator, it brings up the fraction menu. So alpha y equals, then you push enter, and it lets you put in your fraction. So I have 4 over 5 times 6, and it'll show me that simplifies to 24 over 5. Okay. All right. So I found the horizontal change. Let's go to the vertical change. For the vertical change, it's going to be y2 minus y1. Okay. Y2 here is 3. Minus 0. And I only want 4/5 of that change, so I'm going to put my 4 over 5 here. 4 over 5 times 3. And I know that's 12 over 5. But if I didn't know that, I can use my calculator like I did before. Okay. Now, it says to add the horizontal change to x1. Okay, my horizontal change was 24 over 5. If I look back up here, I see that my x1 was 0. And that gives me 24 over 5. 24 over 5 plus 0 is 24 over 5. Now I'm going to add the vertical change. Yeah.
4 over 5, multiply 4 times 3, right?
Yeah.
How did you get 24 over 5?
6 times 4 is 24. Yep. Okay. Now I add the vertical change to my y coordinate. My vertical change is 12 over 5. If I look, go back here, I see that my y1 is 0, so I'm going to add 0, which gives you 12 over 5. Okay. Now it says write the x and y coordinates as an ordered pair. So all I'm going to do is take 24 over 5, comma 12 over 5. That's the new point that I was looking for. And it wants me to graph the line segment and plot the point. Huh? Well, first I'm going to graph the line segment. One point is at 0, 0. And the other is at 6, 3. So 0, 0 is right here in the middle. Let me make that bigger in red. 6, 3 is over here. So to graph that line segment, I'm just going to connect the endpoints here. And that's the line segment. Oops. Okay. And then my point is 24 over 5 and 12 over 5. 24 over 5 is like 4.8 something. You can change it to a decimal, 4.8. 12 over 5 is 2.4. So my point will be somewhere around here. Okay. Now your test, I'll give you a whole number, so you don't have to try to graph a fraction or decimal. But remember, this is bonus on your test.
Go back to part 3. So you got 24 over 5 plus 0 equals 24 over 5, right?
Yeah.
And then you get 12 over 5 plus 0 equals 12 over 5.
Mm-hmm.
How you got 24 over 5 at part 3 and then 24 and 12 over 5 at part 5?
So in part 3, we're adding a horizontal change to my x1, right? So we found the horizontal change in part 1. and we said it was 24 over 5. The second part, we're adding a vertical change to y1, and in part 2, we found the vertical change, we said it's 12 over 5. See? And then the zeros are because x1 is 0 and y1 is 0 in this problem.